Okay, starting up the late night stream. We are at 2,600 kilobits. Hello, this is stream number 18. Working on my parser tool called the DataDisintegrator. Until I have the recap video or description video or summary video, whatever we're going to call it, I have to describe it this way. So this tool pulls apart all the bytes of some binary file or stream and assigns meaning to each one, as in each byte. I don't think I phrased that quite right. Based on a description of the format of the file stream written in a domain-specific language. So, for example, here is a description in my DSL for the GIF file format. So GIF files start with a header and end with a trailer, have some data blocks in the middle. And let's see if this actually runs. The first thing we do is we turn our input program into a token stream. So this is our input program. This is its token stream, right? Second step is the parser. It turns that token stream into an abstract syntax tree. That's this tool, if I can still run it. There we go. Pardon my pauses. A little bit slower than I like because I did a cargo clean to try to look into a problem that I saw off stream. Right, so here is the abstract syntax tree. It should roughly match the input program, and mostly it's just echoing the structure, because that's the whole point, is for the program to sort of mirror the abstract syntax tree. So this abstract syntax tree called GIF is what we're going to then, in the third stage, the ingestion, use to break down binary data into elements to determine their meanings. So, for example, when we are starting a GIF file, we'd start with the header, and then we would basically go in order traversal this. We would go to the signature and the version and try to parse them. So when we do that, we would get that signature out, that version number out, etc. So I've written this tool 5 years ago in C, and I'm porting it to Rust. So changing some of the terminology as I go. So if I show the C versions of things, some of them have old names, like formatting is now parser, decomposition is now ingestion. And I want to get it up to where we were in C, and then add scripting and a user interface to it, and I don't know, play around with it. See how far we get with this project. Mostly it's for fun, doing it in Rust because I like doing Rust. So this morning I was streaming and noticed something right before this stream that I didn't notice at the end of last stream. If I do a check, I see that there's an error, but down here it doesn't say I have any errors. It only talks about warnings. This is actually one of the errors, right? That this is an undeclared crate in this context. I think this is a bug in Rust Analyzer. It doesn't see that that is an error. So I believe it is because we are using in this crate maplet, but it's a dev dependency, not a dependency. I think if I move that up to there, it should solve the error, and now Rust Analyzer should be correct. I should get, yeah, 32 warnings, right? And no errors. That said, it did say that I don't need to use maplet anymore. I was using it for a while because I wanted to encode these elemental functions into a hash map, but I don't think I actually need to do that anymore. I think we're just going to use it with a match. So that means we don't really need maplet anymore. So I can just remove the dependency completely. There we go. I'm going to fix some of the other warnings before I move on. These are all going to fix really soon anyway, so let's keep those warnings. Okay, so they're all in that file, so I don't need to worry about it anymore. Okay, cool. So I'm just trying to get some initial unit tests for the ingestion library working. So these are the tests that we have an example abstract syntax tree that's just a very small program. And actually, you know what I'd like to do here is keep the formatter from reformatting that. When I save, it does that, and I don't like that. So there was a way to suppress formatting. I forget what it is, so I'm gonna have to look it up again. Rust fmt suppress. Probably misspelled suppressed there, didn't I? Here we go. Rust fmt skip, that's what it is. So I want to have Rust fmt skip this exactly. There we go. So now when I hit save, it doesn't reformat that. So here's a little test program. It's a format called foo, which just has one elemental part called bar. I call it elemental because the format is UI, which is a built-in format called unsigned integer. So it will parse the next amount of bits as an unsigned integer. It's like one of the simplest ways we could parse, right? Just take the next n bits and interpret it as a number. It works by using the bound. So whatever number goes in here, so like if for this test it's 8, for this test it's 4, it's going to parse that number of bits as an unsigned integer and name it bar. And then the overall foo will get a copy of the value in bar because that's what the return does. It takes a copy of the value that bar has and assigns it to foo. So then in our test, we would have that AST, have an example bit stream here, so just a single byte, and call the ingest function to do the parsing or the ingestion of the those bytes based off of that AST. And we should get, for 8 bits, we should get the whole byte out. For 4 bits, we should get the top 4 bits out. And then if we call it again on the same bit stream, we should get the lower order 4 bits out. So these two tests together kind of force me to actually do the parsing for real. If I just had one test, I could fake it, which is what I started with. Now with this, since the number of bits has to get all the way into the UI, we have to implement that. And the bitstream has to have enough state to remember that it's already parsed that, so that the second time it parses that. We can't cheat anymore. We have to actually do the real thing. So I was working on the goal is to try to make this test, both of these tests pass, right? So got the byte to pass, but the nibble to fail, and that's because we're still cheating in one place, at least. And let's close all these other things to try to find out where we're cheating. We don't need all of these. Probably not. I'll need that file open in case anyone asks about it. Okay. I think we're indenting enough here to signal to me that I should refactor this anyway. So maybe I stop and do that now. I think what we're going to have this in other places too, where we just want to execute a sequence of statements given a context, right? So I think we're just going to refactor this as a method of self. This part right here. Refactor function. Okay, it made it a free function, but I don't want it to be a free function. So I'm just going to take it all and cut it and then paste it in here. And let's make sure that it says self dot. And then we add, for now, just an immutable reference to self. 25 blue bunny. Boo. Hello. I'm doing arcane programming here that you may not understand, but that's okay. It's all fun. Here's a general rule. You never want to have this many spaces to the left of your code. That's a sign that you are not making your function small enough. So I'm trying to break this up so that they're smaller. Okay, it doesn't know what this B is because this, it didn't put that here where it needed to go. Oh, and let's rename fun name. Fun name is a fun name, but really this is execute statements, right? And this should be an argument. There, so we're going to put statements is a borrowed array of statement. And then we can just say statements here. We have to import statement. Okay, and then I'd like to put the context to the left of the format, just cause. So that means that moves down a line. All right. We're actually not using that. Now, why did it put it in there? Yeah, let's take that out. We don't need that. Don't know why it added that. Cool. Okay, and let's get this outdented too, because that's just execute statement, right? Let's see if this will refactor it correctly. Otherwise, maybe I manually refactor this. So right click, refactor function. Nope, it didn't do it right. So I'm just going to do it manually. This should just be execute statement with a self in front. With statement and context. And then I can copy all of this, right? And then just paste there and say statement, and then statement, and then statement. Get rid of a few braces, and we're done. Okay, we're getting there. I think this match statement is too huge, so why don't we tell it? I'm hoping that the refactor as extract as function will actually do the right. See, it's still not doing it right. I'll just copy that. This should be execute statement part. Paste it there, and then let's copy this stuff. Paste it there. One complicated thing is that we have all these arguments that it might need. One way that we can solve that is by actually giving this a name, a structure name. So what to name it though? Part, I guess. Maybe part. And just essentially take all these and paste them here. And then this is just a new type for part. Yeah, so anything that the outer one derives, the inner one needs to derive also. Okay. So this we can just say that is a part and it'll still work. Look at that. Same thing here. Here though, I can say lowercase part And because then we're going to just say execute statement part. And we'll just say part here instead of statement. Because that is a subfunction. Right? And then here this becomes part. Part. I kind of want to call this statement part. Part statement or something. I don't know. Maybe, maybe not. Make sure that, oh no, we have lots and lots and lots and lots and lots of errors. Yeah, I gotta fix all these places, right? This again. Interesting. Like, it doesn't know it can import it. Oh, because we never re-exported it. Yeah, okay, that's a problem. Let's go ahead and rename this part statement. It didn't rename it here. Oh, it can't. Well, we're gonna export it from here. Right? We need to fix that. We actually need to do the exporting. So that's in AST lib. So here we're going to say not only export statement, but part statement. Okay. I might have to mark all these pub, actually. I think that's what that error was about. Okay, we got more errors. Yep, so this is part statement. One more parentheses. I'm gonna end up adding that in a lot of places, aren't I? Yeah, like right there. And right here. And right here. I'm seeing where all those reds are. We gotta fix them. Up, 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 there. Okay. 6 errors. Oops. Too many parentheses? Cool. Working again. Oh, still have an error. Oh, because of the grammar file is not checked. So if I change anything about the AST and it affects the grammar file, I gotta do this manually here. So part statement. So let's search for where we have like part. So just here, right? So here we have to do that same thing. I think I'll do it that way. Okay. Hey, what Linux distro are you using? We are using Xubuntu. Okay, I got an error in ingestion. How come this isn't seeing it though? To restart the server maybe? Would think that it would be able to see that error too. Okay, fine. We'll just go find it ourselves. Ingestion source ingestion.rs184. Oh, there it is, finally. Yeah, so this needs to be a part statement. And that is statement. And I think what I wanted to do here is do statement dot in front of all these things. And that. And that. And this needs to be imported. And then the same generic has to be applied to the statement part, I think. Although I'm wondering if I can just do that. Doesn't even matter. What does it actually want? It expects one generic argument. Okay, so I have to put a generic there, but can I just put a B there? Oh, interesting. We gotta borrow here. So does that mean I didn't need the little generic context there? Huh. Do I need it there? Nope. Okay, so how many places do I do that? There and there. Yeah, can I just get rid of in both places? Looks like there's one place it needed to be. Up here. For some reason, it needs a lifetime. Eluded lifetime not allowed here. Quick fix. Include the elude. I wonder why it's needed. Oh, right, because it's its own definition. So that's the only place where I need a eluded lifetime. What is an eluded lifetime? The structure is declared as having a lifetime because inside the structure we have a limited lifetime reference. It means this bitstream is a pointer to something, but is a pointer to something that might not live for the rest of the program's duration. It's gonna maybe only be valid for a certain amount of time, but then go out of scope. And so we represent how long the pointer is valid for using a lifetime specification, just a name with a tick in front of it. And then we can refer to it in other places. So for example, in order for the structure to be able to hold a pointer to that borrowed thing only up until it's no longer valid, we have to make the entire structure generic over the same lifetime. When I say generic over, it's over these types and lifetimes. So it means that these things are what can change when you make a value of this struct. So we can change the lifetime of the bitstream, and we can also change the type of the bitstream. Generics can be over lifetimes and over types, and if it's over a type, then you use a trait. So bitstream right here is a trait. In other words, it's an abstraction or a pure virtual class or an interface. There are different words for it, but basically it's a placeholder for any type that can implement that contract. Okay. See, I'm pretending that people are asking me questions and I'm answering them because there are probably lurkers either now or later in the VOD who are unable or just too shy and don't want to ask the questions. So I'm trying to anticipate the questions you might ask and then answer them for you. Plus, I also like to practice explaining things. Don't mind me. Exactly, but now you're not a lurker anymore, Vincent. Or Vicent. Sorry about that. That we have to borrow, right? Yeah. Okay, cool. So we should be out of errors. And only we're still in the state where we didn't regress. That's still failing because we haven't addressed the failure yet. But I wanted to refactor the code so that there wasn't so much indentation. Now it's looking a lot better. So ingest executes the statements of the format. Executing statements is just looping through and executing a statement individually. Executing a statement does a match on the statement type, and if it's part, we execute the statement. That should be execute part statement, I think. Not statement part. It's a whole statement that happens to be a part statement. So to execute a part statement, we're making a new part. I'm not using this yet, but like the to-do says, we're going to want to actually walk through these as we're constructing the keyed children of the part, which we're not doing yet, in order to assign the values of them. Right now, we're just putting the values and collecting them. Mostly because we're not using any formats that require arguments yet. But fundamentally, after we construct the component, we have to figure out how to parse it. And that is by looking at the format. And if it's one of the built-ins, then we call a function to do it. If it's not a built-in, well, that's where we're going to have to look it up and I guess recursively call ingest, because that's what ingest does. Although now that I think about it, there's a problem here, right? This composite is created and put into the context, but I think I want it to be that we start with the part or the composite here actually, and then we want to put it into the context and return, but then return it back out, right? At the end. So we probably want it, instead of constructing it here, we probably want it to be passed in and constructed externally. Because when we do part, we're constructing a few things up front, right? Like its arguments. We'll get there when we get there. Okay. Don't hard code the parsing. Exactly. So that's what this should be doing now. What does that actually do? Yeah, that assigns the data value. Right. So we don't need to do this anymore. So that's what we're going to get rid of. Why did I call it data? Because it is data. It's really it's a data component. I guess we can call it either component, data component, composite. They all mean the same thing. Yeah, so we don't actually need to do this, right? So, do we always do that? Yes, because that's what a part statement does. If it has a name, it becomes a keyed child of the composite. Okay, make sure that that doesn't break it, the nibble one. Okay, so then UI should be getting everything. It's just that probably the bits for our bitstream buffer is not... No, wait a minute. I thought I had that returning the right values. Yeah. So how is the nibble one failing now? It should... Is it passing the first step? Why is it not showing a number there? Is that just a bug? It should be printing something. How come I'm not seeing it? Wow, look at that. It's like a secret number. I have to like highlight over it to see it. Okay, so the problem is that it's failing in the second part of the test. And I have to highlight over that for you to see it. So it is getting the one nibble out, but then instead of getting a two nibble, it's getting the one nibble out, right? Because it's not remembering that it's already parsed those first bits. So that's where we need to work here now. So as a side effect of reading bits out, we need to like advance our position into the bit stream, which means we need to have a position. Let's call it offset usize, right? We will start the position at 0. And then here's where it gets tricky, right? Because sometimes we'll be able to get all the bits right away in one byte, and it'll be the easy case. Other times we'll get some of the bits of the current byte, but then we'll have to advance to the next byte to get the rest of the bits. And that might repeat, right? So what we ought to do is start with let mutable bits equals 0. And at the end, we're going to return those bits. And let's have a record of how many bits left we have. Actually, I guess we could use n for that, right? We can make n mutable, and we can say while n is greater than 0, and then do this. Right? And then this should be no greater than n. So we need to have like if the n is the total number of bits, then we need another name for the number of bits we're getting in one loop. How about n loop? So that should be like no bigger than 8. Actually, it should be no bigger than the bits left in the current byte. So that will be there's standard min, there's a standard compare min, yeah, min. The minimum of the number of bits left, and then I think we would want to do is 8 minus offset mod 8, right? Or yeah, mod, well, and 7 is the same as doing a mod 8, right? And that's self. So like if we're at offset 0, then 0 and 7 is 0, 8 minus 0 is 8. We would get 8 bits, right? But let's say we've read 4 bits. Then offset will be 4, mod 7 is 4, 8 minus 4 is 4, so there'll be 4 left. If like it was 6, or at offset 6, that means there should be 2 bits, right? 6 mod 7 is 6, 8 minus 6, 2. The and 7 or mod 8 is there, so that if the offset has gone in over to bit 8, then 8 and 7 is 0, 9 and 7 is 1, so it's like, this is the bit offset. So if I wanted to be more descriptive, I would say let bit offset equal that, and then let byte offset equals self.offset shift left 3. Right, that's the byte offset, and that's the bit offset. So basically we're dividing the offset by 8 and getting the remainder in bit offset. So this is bit offset, right? How about we say bits left in byte? Okay, then that's where n goes. And that's also where n goes there. So what we're going to do is we're going to shift left. So bits shift left equals the number of bits left in byte, right? Actually, let me think about this. This is the number of bits we want to shift in, but it might be fewer than the number that are left. So actually, hold on. I need to calculate this correctly. The bits left in the byte is 8 minus the bit offset, right? But we also have let bits needed from this byte. That is the comparison of n with bits left in byte. Right? So let's say there are 8 bits left in the byte, but we only need 4 of them. Would the mask be 1 shift left 4 minus 1? No, it would be we need to shift it up by the bits that are left in the byte, actually. Not exactly, right? Because that'll select all of the bits. I need to get the mask. The mask are the bits that we want to add in, right? We're going to do a plus equals something right here. We're always shifting something down and masking it. Okay, so the mask should be in the lower order bits. So this should be the bits needed from this byte, right? But the amount we shift, the input should be the bits that are left, right? Wait a minute, no, that's not right. The shift actually is going to be different than this. I think it's going to be the difference between these two, actually. Shift should be the bits needed from this byte minus the bits left in the byte, I think. Or, no, the opposite. It should be this minus this, I think. Let me think about this. We're always going to shift left by the bits needed from this byte. And then we're going to add in the actual bits. So this should be the byte offset. And then, by the way, the last here is going to be n is the number of bits needed from this byte. And self.offset is we're going to add to that bits needed from this byte. Okay, let's see if I did this correctly. Run through some examples. Maybe I should have a test for this. Well, I think this test is going to test that, right? At least for 1 byte. Let me think about this. So we're starting off, we don't have any offsets at 0. So bits left in byte will be 8. And let's say the bits needed from the byte, we wanted 4. So the mask is going to be the lower 4 bits. The shift is going to be 8 minus 4, so 4 also. We're going to shift left 4. Well, doesn't matter because the bits doesn't have anything in it, right? Then we're going to add that first byte shifted right by 4 to get the upper 4 bits, and then we're going to mask off those lower 4 bits. That's correct. So what if instead of 4, we actually made n2? Then bits needed would be 2. The mask would be the lower 2 bits. This would be 8 minus 2, so the shift would be 6. So that's correct. It would shift it over 6, and we get the bottom 2. Well, let's say the offset was also 2. Actually, let's say the offset was 2, and n was 4. So then there are 6 bits left, and we need 2 of them. Or 4 of them, right? We need 4. So that's 6, that's 4. So we're shifting the mask 4, so lower 4 bits. Bits left is 6 minus 4 is 2. Okay, I need a little graphic to remember this. So if let's number the bits. Those are the bits in the byte. And let's say that we've already read What was my example going to be? We've already read 2 of them. So let's put X there, and so we're here. O for offset, right? Actually, let's just identify the bits that we want out of it. If I wanted 4 bits from, and we've already read 2 of them, then I want those 4 bits, right? X means we've already read them. These are the bits we want, and we don't want those bits, but we want to keep them. So this is going to be 2. Where do I write a 2? Right here, maybe. Bits left in byte is going to be 6. So bits needed from this byte is the lower of these 2, right? No, the lower of this and n, which is 4. We want 4 bits. We have 6 bits, so that is correct. This will be the lower of the 2, so it's going to be 4. Because we only need 4 of the 6 bits, right? So then the mask is going to be, let's write mask here. Bits needed from this byte, so it's going to be the lower 4 bits. And then the shift is going to be bits left, which is 6, minus the bits needed, which is 4. So that's going to be a 2. So it's going to shift left bits needed, which is 4. Yeah, because we're about to add 4 bits in, right? Then we're going to take that byte, shift it right shift, which is 2. So it'll be all in position, and then we mask them off, right? 4 of them. I think this is correct then. So let's say we needed 6 bits. So we wanted all of those bits, right? If that's 6, then these 2 numbers don't change, but this would now be 6. And bits left minus bits needed is now 0, so we're not shifting any. Yeah, so we're still, the mask is going to be bits needed, so it's the lower 6 bits. So we're not shifting any, and then we're masking off the top 2. That's correct, right? This is all looking good so far. Now, let's say we wanted a full 8 bits. Then this is still 6 because the lower of 8 and 6 is 6. And that's still 0, so we're still only shifting, we're only getting the lower 6 bits, and then here it goes down to 2. Offset should go up to 8. I think this is actually, I think this will work. If it doesn't work, we'll go fix it. How about that? I'll give it my seal of approval so far. So let's just run it and see if it passes our tests. Hey, look at that. Maybe I should make it a little bit more difficult. Let's have it be a little bit more difficult. So let's have it read 5 bits at a time, and we're going to have 2 bytes. 1, 2, 3, 4, right? So 5 bits. Can you do binary in, can we do binary literals in Rust? I don't remember. Rust binary literal. Because that'd be easier to see. Oh, it can be 0B? Ah, great. So we can have binary. Cool. That's what I want. So 0, 0, 0, 1, 0, 0, 1, 0, and then 3 would be 0B, 0011, and then 4 is 0100. Okay. So then if we read 5 bits at a time, we're reading these 5 bits, so that's a 2. Or actually, let's just do in binary, right? And the next 5 bits would be 001000. 01000. And then one more time would be 11010. 11010. So this is in test ingest 5 bits at a time. Cool. Now let's do values larger than 8 bits at a time. So let's have I'm thinking like having like more than 2 bytes here and just continue the pattern. So we'd have like 0B, so that was 4. Let's do 5, 0101, and 6 is 0110, and 7 is 0111, and 8 would be 1000. Okay, now let's do like 9 bits at a time. Right? So 9 bits would be 0001, 00100. So we're here now. So that's the next 9 bits, right? So just copy, and I'm going to paste there and get rid of the break and the 0B in the middle, right? So the next 9 should be these ones right here. So this is ingest 9 bits at a time. We're awesome. We passed it. Hey there, the Rhodium Man. I look like Tony Stark. Where's my Iron Man suit? How are you, Rhodium Man? Rhodium's a rather heavy metal, isn't it? Atomic number 45. Where's rhodium on the periodic table? Why is this so slow tonight? What's it doing? I just want to see where it is. Oh, there it is. It's right next to palladium, above iridium, and below cobalt. Yeah, these are the heavy metals, right? The heavy and expensive metals. I guess it's one row up, so it's not exactly a heavy metal. But it's near palladium, which is a very rare and hard metal. Okay. I just couldn't remember what rhodium was. It's the toughest metal in the universe. I thought that was wolframite. Tungsten. I thought tungsten was tougher. Why didn't keyboard work? Wait. How come Nightshade Dude typed it and it didn't work, and then I typed it and it did work? Oh, maybe my bot has a problem if you reply to someone else with a command. I'll have to look at that. Let's see. Oh, I'd have to look at my bot's log. Okay, I just saw Flask type and it says the command is not yet cooled down. Now it's cooled down, so try it again, Flask. Actually, but do it as a reply. Okay, you didn't do it as a reply. But I bet if we did it as a reply, it wouldn't work. So that's a bug in my bot. Should I make a note to fix that? I should, shouldn't I? I have a to-do list. I should write here. fix bug in bot. Commands in replies don't work. Yeah, it wasn't. Okay, now it's cooled down. Now try it. Someone would do a bang keyboard, but do it as a reply. We need someone to do it. Or I guess I could do it. Yeah, someone else. Yeah, so it's broken. We can't, the bot doesn't recognize the command if it's done as a reply. I'll fix it. One of these days. Yeah, it just doesn't even know you guys are asking it to do a command. But yeah, you want to see the keyboard? Look at that. We designed this, chat, last year on stream. Cool. So I'm just working right now on a bitstream, a bitstream buffered bitstream. So it holds. We can show you. It holds a pointer to some bytes, and it remembers where it is in the bitstream. And then when you ask it for a certain number of bits, it reassembles it, and it's a little bit complicated now because we like this these unit tests show we might ask for 9 bits, and so like this is actually the first 8 bits plus 1 bit of the next byte, and then this one's the last 7 bits plus the 2 bits of the next byte, and this one is the last 6 bits and then 3 of the next byte's bits. How much that keyboard cost? I did a breakdown at some point. Let me see if I can actually I can literally do a new window, right? And then open the keyboard project, and I think I had a bill of materials in there. Let's see if I put it in here. I think I did. I think I put it under README. Let's see that in a nice way. Preview. Preview. There we go. Maybe near the top. Around here somewhere. Here we go. Here are the parts. Oh, I don't have cost associated with them though. I should have done a cost breakdown, right? So this was pretty cheap. I think it was only like $10. Yeah, this was super cheap. There was like maybe a dollar or two. That's the socket for that. These were a little bit. The diodes are cheap. The switches were a lot. I should have like shopped around to get cheaper switches. Keycaps, I don't know, like $10. These ones are kind of pricey. That's a specialty part from NeoPixel. Adafruit sells them. Same thing with that. So I didn't need these. Those just gave me lights on my keyboard. These are cheap. USB cable, cheap. Well, relatively. That's maybe like $5 to $10. Don't actually need these anymore because I didn't actually use the brass anymore. I actually went and used nylon instead, and that worked out a lot better. Same thing with this. Nylon screws instead of the metal screws. I need to revise this because that's the original parts list, and now I'm using nylon screws and nuts. Rubber feet are super cheap. And oh, that's just connecting for the computer, so it's like another $5 to $10. All in all, it's actually a pretty cheap keyboard. Yeah, the switches were, I think, by far the most expensive. And I think I could have got a deal on the PCB socket, the Kale sockets. If you buy them in bulk, you get them for cheaper. I spent too much money on the LEDs though, definitely. That I think inflated the cost. I think that doubled the cost, probably up to $100. Yeah. So if I wanted to do this cheap, I would not buy the LEDs. Actually, it would save me a buttload of time too, because those are the hardest things to solder on the board by far. And then I'd probably try to get a deal on Cherry switches. The rest of the stuff, if you buy it in bulk, particularly, it's really cheap. So yeah. Yeah, when you think about it, most of the cost is just my time to do the soldering, because that has to be redone for every unit. So maybe the PCB designer, if you find a PCB designer, they can do the assembly for you, but I don't know if I trust them. I don't know. They'd probably do a good job, right? I also had to spend some money for the plastic for my 3D printer to print the shell pieces, the clear pieces you see like that it sits in, and then this little cap here for the CPU. Oh, and the keycaps. If those vary in price too. But is it better compared to a Kness Professional? Well, I made it myself though. I mean, there's like a sense of pride and that I made something. It's not as good as a Kness or any other keyboard. I hand constructed it, so it's not going to be and nowhere as good as a professionally made one. Yeah, exactly. Nerd pride. You got it. Okay, so this is working. I'm happy. We went a little bit excessive on this test format. This file is of a decent size, and I'm thinking I should move the tests to different modules. And so we should just establish that now. So there should be like a tests rs, and let's just start by moving the tests there. So that's basically just taking all of this out. Cut tests. Did I make that a folder by accident? I did. Let's rename the folder just tests. Make a file called, no, not there, a file at this level called tests.rs. And then here we paste. And then in lib, we have to say config test mod tests. Right? So this should still work. I should be able to run all the tests, and it does work. All 4 tests passed. But now we've pushed it into its own module, and then I can put these into a submodule. Why don't we make these all in common? And I take these and put them into a submodule. So we'll make in tests, I don't know what to call them. How about like simple format and paste. And then before I hit save under tests, I want to do like mod simple format. Hit save there, then hit save here. And then we just do a use superstar again. Normally I don't like doing glob imports, but I think it's okay for tests, especially if they're structured like this, where they're really just separating tests in different files to keep it easier to organize. And I can still like run all the tests like this. For tests seem to make sense? I think so, yeah. Okay. Now did I get away with anything here? Did I get away? Was I able to cheat here? I think I was in the reference, right? Yeah, that's cheating. So I should make a test that forces me to not cheat here. One thing we could do is we could put it 2 levels down. So let's make another test file called ref tests, references. And under tests, we'll have a mod references. And let's copy from simple format. Just copy everything for now. And then close that. Okay, now let's devise I'm kind of thinking that this should just be called like build AST. And it's a local function, so back over in simple format I can call it that too, right? And that could just be a convention that all the tests build an AST with things that vary about it for the test, if anything. So in references, let's just start, we don't have that. And we just make this like an 8, because I don't care in this one. But I want to have two, the important thing about this is I want to have two formats. One called baz, let's say, and then let's say that this is a baz, and then we want to return baz.bar. That's going to force this test to go 2 levels down. So go into baz, and then the baz go and get the bar out. And in fact, I'm not going to return anything here because I want it to only be available as bar inside of baz, right? Oh, this compile formats is common, so why don't we move that out? That can go up here, simple format. Let's move this out. So cut that out. Cut that out. Cut that out. And put it here. And do I mark it public? I don't remember you have to mark it public. I think you don't have to. What's the... Oh, right. That, yeah. Okay, so we don't have to mark it public, right? It still works here. This, we just broke this by accident. So, actually the same thing with ingest, right? That can just be a common function as well. So this doesn't need its own local definition. Okay, cool. So then it's just the AST is different, and then okay, so we're gonna build an AST. Let's get rid of all these other tests. Build an AST, and the test is gonna be like 2 levels. We're gonna build an AST, and then what's the useless format? It's not a useless format. Oh, it is a useless format because we don't have any arguments. There. Thank you, Clippy. And that's already a static. Okay, cool. So then we got to give it some byte because it's going to parse it as byte. It's going to ingest it as foo, and we should get return. We should get that out. So this is going to fail right now. Yep. It's going to fail with the parser error. Why did that part? Oh, because that is not a double. That we only do that when it's a format. Okay, try again. It's like it didn't fail the way I thought it would do. What's wrong with this? Let me try to restart, reload. There's something going on with the font in the terminal. Just saw my keyboard video on YouTube. Looks pretty hard work. Oh, well, thank you, Rhodium Man. It took several weeks, and it was a mix of things that I already knew and that I learned. So I learned how to do PCB design, which was really fun. I really like doing the trace layout. I learned how to use diodes with key switches to prevent ghosting, and I learned a little bit of the USB stack. Yeah, all around it was learning little bits and pieces. Very approachable project, by the way. If I'm going to build almost anything else for my computer, it would be really tough. Like, people suggested I try building a mouse. Mice are very difficult to build because they're very, if you're going to make a ball mouse, it has to be very precise machine parts. And if it's going to be like a infrared or laser mouse, then you have to have like a DSP with an image sensor. And what's ghosting? That's where you hold down 2 or more keys and like an extra key. It thinks that you hit an extra key that you didn't hit. And that happens if you don't have diodes because the circuits get closed. Too many circuits get closed. We could probably find an example here. Keyboard ghosting. Interactive demonstration. Here we go. Click to start demo. Oh, that's my keyboard. Mine's not going to have ghosting. Why should you care? Is there no example of it? Just ads? How about image search? Here we go. So I think what it's trying to show is if you press the S, then this column is all shorted and this row is all shorted. And if you were to then also hit 2, it would short that whole row. And now if you hit 4, it would short that column, and it would think that you hit the F, even though you're only hitting S, 2, and 4. It would think that you're also pressing down F because it can't tell it. If you short this row and this column by pressing, I guess actually all you need to do is press S and 4 at the same time. Press S and 4 at the same time, you short this whole row and this whole column. Now, where they intersect, the 2 and the F would appear that you're hitting it. And diodes prevent that because there's a trick where the current doesn't feed back out to any other switch. So like even though it enables that row, it doesn't actually send current through any key you didn't hit because it's hard to describe. You set up the diode in a certain way that for these it would all be the wrong way. Like current only flows out of the key if you hit it. So it could flow out of D, but you'd have to actually also be pressing it. I'm not explaining it very well at all. I mean, I'm very very much a newbie or like a novice when it comes to electronics. So I basically stole the schematic for a non-ghosting key switch, which you arrange the key switch and a diode next to it in a certain way, along with the column and the row. It's like the columns are inputs and the rows are outputs, or vice versa. If you arrange it a certain way with the diode in a certain direction, then you don't get ghosting. Diode power is clear. We didn't quite understand ghosting until now. Yeah, that's probably because I didn't really talk about what happens if you don't have the diode. On some, you think there's another problem where you only hit like 3 from a single zone and any additional keys will not register. Oh, that's probably because they don't have a diode for every key. So I splurged and put a diode on every single key. But you can get away with fewer diodes. It's just that you have limitations like that. That's my understanding. N-key rollover is different. N-key rollover, I think, is where there's only a certain number of keys that you can report. Okay, I might be getting my thing screwed up. Let's look it up. N-key rollover. What does that mean? What is N-key rollover? Allows the user to press multiple keys at once, registering each key pressed individually. Registered separately. If you press 3 character keys at once, all of them will display. However, there are limits to the number of keys you can press. It's represented by the N. This didn't really explain it very well, did it? I want like a more technical explanation. Yeah, we know about ghosting, and that has to do with the electronics of it. Controller was told to ignore this key combination in order to avoid ghosting. Well, but we don't. A diode for everyone prevents that. Row of keyboard connected by grid of wires called, okay, so it doesn't show it because I'm doing dark mode, so we can't really see the illustration. Yeah, this is ghosting because we don't have any, yeah, they're actually showing the ghosting. We're pressing the B and we're pressing the C, but it looks, and F, but it looks like E is registered. See that? B is closed, C is closed, F is closed, but E is not closed, but it still registers because it sees current going from column 2. So if you don't press anything and you close E, then the current that goes through column 2 ends up on row 2, right? Because it would be closed. But if you closed B and you closed C and you closed F, then the current goes this way. It goes through B and then feeds back through C the wrong way, and then it goes through F, and then you end up on row 2, right? So the way you prevent it is if there was a diode on each one that only let current go from top to bottom, then it would go down through B, and then it wouldn't go up through C even though you had it pressed. So it would not go and connect back to row 2, even though you closed C. That's how the diode works. But how does that have to do with like 6 key rollover? Because if you put a diode on each one, then you don't have any roll like limit. Okay, from what I can remember, and I think this is what 6 key rollover is, in USB's USB class driver, there's a message back to the host to say how many keys are active, and it only has 6 slots. So you can only really hold down 6 keys, and then the 7th just doesn't register, right? But you can get around that if you use the newer protocol in USB, and I can't remember what it's called, but there you'd use a different message format that has a much larger register. I just don't, it's been a year. I don't remember exactly what it was. Okay, yeah, I wanted to see if this fixed my display problem. Okay, cool, it did. So we have something that's not yet implemented. Oh, right. That's right, because this test referred to a custom format. We have to handle we have to handle it here. So the way we would handle is if we would look it up in the contexts formats, and if it's there, then we would recursively call ingest. Hold on, I think the dog wants in and my son's not hearing it. Scratching. Guess I misheard that. See, if I mash keys, I don't have a limit of 6. Oh, maybe I do. Yep, I have the 6 limit too. I thought I didn't I do the other protocol? Maybe I didn't. So maybe I'm also limited to 6 also. It was a USB limit though, right? Now I'm kind of curious to go look. Let's see where we did that. That would be in like the USB report, right? So that's in the firmwares. Let's close all this junk. Firmware source. Keyboard. Processing. That's a update keyboard report. Update host HID report. Here it was. No, it's update keyboard report. If USB is configured. Well, that's just sending something else out. Where do I actually... I think it's this keyboard report. Yeah, there's only 6 key codes in it. This is part of the USB human interface device. That's right. So this is where 6, what do you call it? 6 key roll off, 6 key rollover happens with USB because the USB's keyboard report is limited to 6. Yeah. And that's right. I thought about updating this to support the newer spec, but I didn't end up doing it, right? I did do multimedia key support somewhere. Yeah, I have a media key report, but I didn't do the other kind of. So where is this done? Final references. Polling. Here we go. This is where we update the USB stack. Yeah, I just did the HID keyboard and HID media. Right. This descriptor, right? So somewhere in here is the more advanced way you could report it, and I just never bothered to do it. You can actually have your keyboard pretend to be a mouse, by the way. Yeah, this is limited to 6 key codes, but where's the more advanced one? System key? I don't remember where it is. Maybe that's why I didn't do it, because I saw it was in the standard, but the USB HID crate didn't have it, didn't have support for it, maybe? That could have been it. Yeah, the hardware can do more. We just can't support it because there's a bottleneck. We can only put 6 key codes in the keyboard report. So that's with this traditional keyboard report, which uses. See, the problem is this is more widely supported by operating systems. The newer, more advanced one where you can have more key codes. Well, for one thing, it's not supported by this Rust crate at all, right? Because it's not. I don't see it anywhere here. But the other problem is that theoretically, fewer operating systems would support it. But I think all the major ones do now. That must have been why I got stopped by it. I saw it in the USB spec and I saw it in some other keyboards firmware, but I couldn't do it because I would have had to manually do the that part of the USB stack, and I didn't want to have to mess with this junk. They already had the stuff I did add, like I wanted the media keys and the system keys. What do I want the system keys for? I forget which one of these, but I'm doing one of this. I thought I was doing one of the system keys. I don't remember what it was. But it's like if you want your keyboard to wake up your computer, I think you would use a system control key. Yeah, that's why then. I thought I did it, but I guess I never did. Maybe I played around with it and just didn't, and just took it out afterwards because I couldn't get it all working. I don't remember now. Yep, so my keyboard's got limited to 6 as well. Okay, we need to implement this. So what we're going to do is we're going to say if let some, I guess it would be format, right? Equals self or context dot. Oh, wait a minute. Do we not have access to the formats? So we have it through self formats, not context. Self.formats. Self.formats.get format. Else. We'll make the else something we do later, or maybe I do, for now, I do an unwrap. And we'll fix the unwrap later. So that gives us a format, and then we just recursively do ingest, right? Self.ingest bitstream and the format name. Let's put that here. That gives us back. Oh, right. I wanted to turn this around. I wanted the data component to be passed in. So, composite data component. So we put it in and then take it back out at the end. So then here I would put it in which slot? Right after bitstream. We would put the part in here. Wait, what? Context.bitstream? Yeah, because that's going to form an inner context for that part. But it's going to pass it back out, so I need to say like part equals that. Because then we're going to insert it in there later. If I didn't do that, I think I'd get an error, right? Why am I not getting an error? I'm getting an error somewhere. Oh, right there. Let's fix that one. Yeah, we have to do a new data component, new format. Now we see where the other error is. Yeah. So it says it's moved, right? Use of moved part. So we can say part equals that. And why did it not let me do that? Cannot borrow self as mutable. It's behind a reference. Oh, ingest is mutable? Why did I do that? Why did I do that? Oh, is that because... No, it doesn't need to be mutable. I don't know why I did that. Doesn't need to be mutable. There, I solved it. I solved the problem. Okay, let's see if that fixes the panic. Unwrap on a none there. Okay, so now it's where it should be. So it can't find this first name, right? It should be able to find that name. Let's do a debug. Here, run that. Baz. Shouldn't it be able to find Baz, though? Okay, why? That means I made a mistake in ingestion. When it found Baz, it should have... Oh, it didn't have a name. That's right. I wanted it so that if there is no name, but it has a format, the format can double as a name. So, it should be name dot or option B, which is statement dot format. Found a reference to a string. Oh, sum. Actually, I guess or sum turns into or else, right? this is an option string. Borrow or option string. What's the problem here? Oh, do I need to do this? Actually, it would be as ref, right? Or this as ref. Can't do that? Why not? Oh, I just do that, I think, right? There we go. I did it. It took me a while. Yeah, but I think or some, can't you just do like, or else? Like, that's a shorthand for that, right? Maybe not. Oh, or else it takes a closure. Okay, I always forget these. I gotta look them up. So, cheat sheet. It's option. Where's the or? Here it is. Conditioning or another option to turn an option or else. So there's no T turns into an option? I would think that there'd be like an or and then T turns into an option T, but there isn't. Then there is no shortcut. It's just or sum. Okay, so let's watch that work, hopefully. So it should find Baz, but then it's not going to get a value, right? Yeah, it's going to panic. So it found Baz, and it's going to... Right, so it doesn't find a value because it should iterate over R0. So I basically want to reduce this, right? So it would be R dot 0 dot reduce. Well, iter dot reduce. So, or is it fold? Hold on, let me think about this. I think I want to do a fold with self-composite. So the init is self-composite, right? Self.composite. And then each level basically looks up in the keyed children of the one before. And then we would end up with the innermost level. So that would be a part. Fold composite, and then this is an reference part, RP. And then, so what do we do with, oh, this has to be like a part and a reference part. And what we're supposed to return is the next level part. So that would be RP dot, no, it would be part dot keyed children dot get RP. And here we can skip the indices, right? We can just do RP dot ID. Probably wants me to borrow it. Right. This right now we have to unwrap it. We'll have to handle an unfound reference later. Yeah, we need to borrow that. Okay, so that part is going to be a data component, and then from that we return its value. So it's part, and then the dot value dot asref clone. expected a result? What did I have before? Oh, I had an okay around it. Okay, so this should make it work, right? Yeah, now it works. Okay. So that gets us closer. So we're doing the following the dot trail down, but we have an unwrap here and we have an unwrap here, and we're also not using the indices. So as we make more tests, we'll uncover where these unwraps need to be handled and the other things used that aren't being used. What's that sound? Oh, I have a kitty loose in the room. Come here, kitty. Are you eating a spider? I have found a cat. Apparently, this kitty was eating a spider in the corner. I should probably leave the door open so she can get out. I'm kind of on the fence about whether I should let her eat the spider, though. Because spiders are our friends. They eat the ants. But it does keep her entertained. Okay, so this tests 2 levels bar bass, right? Okay, and then simple format tested 1 level and it tested the UI. So I guess it's up to me. What do I want to do next? Yeah, she's getting supplemental protein, right? Okay, now I think she got behind. Oh no, she left. I'm like, I thought she got behind the green screen, which would be a problem. It's past 10 o'clock already. I should probably go to sleep and continue this in the morning. But let me do one more thing. What do we want to work on next? One of these many warnings, I bet we should handle. Well, which one would be easy to do? Well, there's a lot of easy ones to do. Should I do decimal while I'm at it? Could do decimal. We could throw that in here, right? Maybe not here. I guess we'll just have another. It's cheap enough, right? We'll just have another another test module. Decimals. Tests. Mod decimal. Copy from here. Paste. All right, so test decimal. The AST will just be F or D? I can't remember what it is. Or should I just have it be a literal? Return 3.1415926. There we go. So we don't need a bitstream at all. Ingest bits foo should give me data value decimal 3.1415926. Yeah, which it doesn't exist in data value yet, so we'll have to add it. F64, right? Okay. This is gonna fail. What's the error though? Oh, yeah, it's incomplete. Actually, what's the error? Refutable pattern. Oh, this used to be irrefutable. Right, so I have to actually make that it's like I have to have an else, right? It should be like if let. No, it'll be an else, and we're gonna have a to do. To do. If it's not an integer. There we go. They should give me an error saying I used pi. It's just a coincidence. Allow approximate constant. Oh, that wasn't the real error? Oh, I can't put it there, I guess. What's the warning here? I guess I have to put it on the whole test. That's funny. You just can't use that number bare because it becomes an error saying you should use pi. That's funny. I didn't think that Rust would be that like opinionated. So it's gonna fail because let's see where the first place it hits. It hit a not implemented here. Right. It doesn't know what to do with the literal decimal. Well, that's easy, right? We just say it's okay. That's a decimal. Easy. Run the test. Passes. First try. I also want to test with a parsed decimal. So I'm thinking we're not gonna have one AST anymore. We're gonna have a couple of them, right? Compile formats. That. And we don't need that. Okay, and then we're gonna have another test. So this is test literal decimal. And this is test parsed decimal. Problem is that I don't know exactly what bytes to put to make this floating point number. We'll just do it in 32-bit. That way we don't have to do 8 bytes. But there's gotta be a web page for this, right? So like float to raw byte. Why do it yourself when there's a website that'll do it, right? Online hex converter. Here we go. Can I just put in like a number somewhere? Float. I guess it wants me to put raw bytes, so I want the other way around. Online. Here we go. Someone's got to have made this. Here we go. I want 3.1415926. There we go. Here's our raw bytes. So that, as a 32-bit bloat, should be parsed as that. So then what we do is do D bar, I guess. 32. Actually, I don't know if I have such I don't know if I have bothered to do that in the C version. Let me look for UI, where that shows up. Here it is. Do I have an elemental for floating point? I do. It's called D. So it's supported up to 64 bits, it looks like. And I did it with the union. Interesting. Well, that would be one way to do it, right? You read the bytes into as a UI. It always read 64 bits? Wait, what? This is hard-coded to be 64 bits? Huh. What if it's less? What's this .ui thing? Oh, unsigned integer. Yeah, it had built-in little endian detection. Yeah, it looks like a hard-coder to be 64. I mean, I guess that makes sense. Because if you didn't have exactly 64 or you didn't have 32 bits, then like it doesn't make sense because the standard, the IEEE standard is it's either float or it's double, right? And there's other like there's long double, but we're not supporting that, I guess. I don't know, this seems rather contrived. Maybe I don't worry about this one right now. Maybe instead of decimal, I should be doing like bit or string. I did have it though. So what? Does that mean I should just do it? That's why I didn't check for a limit greater than 64 because it uses exactly 64. This one did check too many bits. Okay, I think I'm convinced. That means I don't need a limit. It's just parse it as it's got to be 64 bits. So I need to do long double. Where's long? Or not a float, but a double. I thought there'd be something where I can do a double. Tools? Nope. Well, I guess we're going back and searching for another one. We need like double the raw byte. There we go. 3.1415926. Convert to binary. There we go. The first two bytes are, oh no, the first byte was the same, and then but then it changed, right? So there, and there. We comma 0x. Okay. So there's a test. This is going to panic because it won't find D. Panic right there. So we need to add D to here, I guess. Elemental D. We actually don't need the bound. We're tossing the bound for now. Just going after that spider again. The scratching going on. Actually, are you going after the spider or are you going after other things? No, don't go after that. Get at it. Go, get. Just like messing around with behind my desk. D here, right? Wait, what? Wait, what? I need to copy this. No, don't. Get out of here. Hey, get. She's behind the computer now. Hold on, I gotta go catch a cat. Here, come chase this. Here, chase this. Come on. Got you. Get out of here. Caught her. That was easy. Ryan won, cat won. Copy. Paste. D. No bound. Okay, so this is we're not using the bound. Some decimal. Okay, so we need like the bits, right? Let bits equal 64 bits. Okay, and then I need to like reinterpret those bits as if it was so let D equal, so there must be a way to like transmute a type. Let me look what that is. So Rust interpret U64 as or bits as F64. Nope, that's not the answer I'm looking for. Convert bytes to U64. Here we go. U64 from BE bytes. There's got to be a way to like actually just transmute it in place. Is there like U64 F64 transmute? Is this what I want? Transmute in memory? Interprets the bits of a value of one type as another type. Yeah, that's exactly what it is. But that's unsafe. I guess I can wrap it with unsafe. Okay, so it's source to destination. And it's in standard mem transmute. Standard mem transmute. Bits. F64 from bits? Huh. How does that work? F64 from bits, okay. F64 from bits. And it doesn't need to be, oh, there we go. Not unsafe. Cool. That's the answer. So we're done. Let's test it. Decimal. Run the test. We failed. We fail. We got a none back somehow. Oh, yeah, it's because that's not what it is. It should not be data.value. I have to do a return bar for that to work. Hey, it worked. 7 tests passed. Okay, I think I do want to finish the intrinsics, so, or the elementals, right? So I don't have bit, which is easy. UI, we have D and we have S for string. So bit and S are all the ones we need. So let's make another, let's just copy decimal and call this string. Tests, we'll do a mod string. String. Oh yeah, we'll have a literal string and we'll have a parsed string. It's literal string. Hello. So we get this out. So we should have a data value string hello. All right, so if instead we have an S bar, return bar, how good am I at my ASCII? H, isn't that 6A? I'm probably way wrong. H. Oh, right, it's 6. I was pretty close, 6-8. It's 65, right? For an E. Yep, and then L is 6C. And then another 6C. And then O, 6F. And it's the same string. So here I have to give it in bits. So that's 5 times 8, or 40 bits. Okay, so string doesn't exist until we add it. Then we go back. Oh yeah, we gotta say 2. This needs to be owned. Okay, and then I'm just gonna run our string tests. Here we go. Okay, we panicked here because S doesn't exist. So let's add that. S, and we actually need the bound this time. Okay, elemental, let's copy from UI. DS, because we need that bound again. It needs to be an integer, so data is some string. I think the way I want to do this is just, we're going to just build this, we're just gonna read it byte by byte into an array, and then we're gonna do an array, we're gonna do a string from string lossy, or to string lossy, or whatever that is, right? So, because we don't know how big it is beforehand, we're gonna want to put this on the stack, right? So let, or I could just do from 0. Well, I guess it's gonna be that divided by 8 in the end, right? Let bound equal bound divided by 8. Okay, and then let s equal, well, bytes equals 0 dot dot bound dot reduce? No. I just do for each, right? No, I don't really see, I don't need. Isn't there like just a way to run a loop a certain fixed number of times? I just want to run this a fixed number of times, so I guess that would be a reduce. And not care about that, right? The f has to return something, though. I just want, is it just for each? Yeah, I think that's it, right? And then we just don't care about that thing. Okay, so we get the bits out. And this is an 8. As you 8. Dot collect into a vector. Actually, I don't remember if I have to collect it. Expected that y, oh, because for each, it's map. Okay, so we get a vector of bytes that way, and then I want to do like bytes, well, string. Or is it bytes? To, I can't remember this stuff. Come on, Raimu. I just have to look it up in the Rust docs. It's something lossy. Or, here it is. It's from UTF-8 lossy is what it is. From UTF-8 lossy. And it's a method of string. So it's from UTF-8 lossy. Bytes. To string. And that goes in here. Why is it letting me go over 80 characters? It's going over 80 characters, going to 81st character. How could you? Oh well. Okay, so run the test again. Okay, so we passed the parse string, now the string literal. That's easier, right? You just need to go to the not yet implemented and actually implement it. S. Okay, string s.clone. All right, and then one built-in left is the bit. So we're going to add a copy of string, paste, bit, tests bit, bit. There's no literal bit, is there? So it's just one test then, the parsed bit. So test bit. So it's just bit. Return bit. Simplest I can make it, right? So let's do like an interesting thing. So it's like a 0 and then a 1 and then a 1 and then a 0. Like that, and then we'll just call it 4 times and expect to see those bits. So expect a bit I think it makes sense to just actually make it just yield an integer 0, right? And then a 1, and then a 1, and then a 1, and then a 0. Okay. Panic here because we don't have the built-in. So it's kind of like a D, right? Because we have no bound. I wonder why I didn't just name it B for bit. I should just call it B, right? Maybe I'll rename it. But I'm trying to do this without actually changing a whole lot. Wait, what's going on here? Oh, I don't need to do that? I can just do that? Interesting. That's true though, right? That's because ingest does it internally, right here. Okay. I'm cool with that. So then I just need an elemental bit. Simplest thing we could do, right? It's just going to be like a UI of 1. It's really just an alias for that. So let's put it at the top. Elemental bit. There's no data bound. We don't need to do this. It's just read 1 bit. Easy. 10 tests passed. First try. Oh, okay, yeah. It's probably good stopping point. Gotta go sleep, but I'll come back to this in the morning. Basically, I got to keep writing tests until all the warnings are gone and all the unwraps are gone. So actually, maybe the next thing I work on is I get rid of the unwraps that I have. Also, I just realized that if we run out of bits, there's no way for the bits function to tell us that. So I also need to do here add a way to signal end of bit stream, because that would be an error. We'd have to print an error like we ran out of bits, right? And everywhere we call bits, then we might have an error. So when we need to deal with those errors, right? So I kind of want to get the elementals like all done, because then we'll build off of those. So these unwraps have to go away. All the unwraps, and this is going to be one of them. In fact, why don't I just do that now? Why don't I just change this to be option so that it's none when we're out of bits, right? And then that means all these places where we call it, we're going to have to unwrap right now, because we're not prepared to deal with an error. And that also gives me a bunch of places to search for unwrap to work on. Option. Actually, we can do this one, right? It's if we run out, if the offset goes past the end. So I guess we would do it here. If self.offset is greater than or equal to self.input.length, return none. Otherwise we have some bits, right? Actually, I don't want to do it there. I want to do it if we need more bits and the offset is at the end. That's what I want to do. Oh, and this needs to be times 8. The length times 8, because the offset's in bits, but the length is in bytes, right? Yeah. Yeah, for buffered bit stream, it's always bytes. I'm thinking other kinds of bit streams, not necessarily will be bytes times 8. but this one is. Okay, that we should be still good, right? Okay. So yeah, I think all the places we have warnings that we're not using things, and all the to-dos and all the unwraps are the places that I can attack next. And I think I want to start with the elementals. So we have an unwrap there. Yeah, basically the only error you can get from elemental bit is you run out of them. For unsigned integers, the expression might not be okay. For the bound, and we also might run out of bits when we read it, and also the bound might be bigger than 64. I should have a check for that. I suppose that we make that a limitation of, or some check we do on the bit stream, right? I can do that now. Yeah, why don't we do that now? If n is greater than 64, return none. Actually, I don't want to have it return none though, because then we can't tell the difference between end of bitstream and an unnaturally large thing. So maybe I look for all of the references. Oh, it's not going to be referenced directly from here, so that's not going to work. But if I go to here and I go to this and do all references, then I can see them. That one's fine. This one's not. So let's do a to do. Check to make sure bound is less than or equal to 64. Actually, 0 is less than or equal to bound is less than or equal to 64. 3, actually, right? Because integers limited to assigned 64-bit value right now. I should probably fix that too. I think I'm going to put that in the to-do though. And be able to parse a full 64-bit unsigned integer. Right now we can't do it because the value type in data is signed 64. I'd have to have like an unsigned integer. And now I have a problem where like I might have to convert between the two, and I don't have that in the C code. The C code artificially limits it to signed 64, which is 63 plus sign. So I'm going to leave that for later because, again, I'm trying to focus on porting the C code as is. But I do need to have that checked. The bound has to be within that range, right? Saying that unwrap is if we can't get 64 bits, right? And maybe we want to have it to handle 32 bits. Be able to parse a 32-bit decimal, aka float. Okay. String. We do want to make sure that bound. Actually, there are two things it needs to be, right? Check to make sure that that bound is greater than equal 0 and bound mod 8 equals 0. Right now we're just truncating it. So I think that's what I'm going to work on tomorrow. I'm going to work on all of these unwraps and all these to-dos within the elementals. So I hope you'll be there. It's about, let's see, 9, 8, 7. About 20 hours from now? No. 4 from 12. About 8 hours from now. I can't do math this late at night. You'll be there? Nightshade, dude, are you like always on Twitch? You're like me, you're like a Twitch addict. You're always on Twitch. Okay, well, hope you guys had fun. Let's go raid someone who I haven't raided in a while. Wow, Quantum Apprentice has 44 people watching? Sure, we haven't raided him in a while. Let's do that. Raid Quantum Apprentice. I'm not sure what he's working on, actually. Wait. What happened to the raid? Did I cancel it? Hold on, let me refresh that. I don't know why the raid got canceled. I must have hit something bad. I didn't think I canceled it. Weird. Oh, and I learned recently that that there's no more hosting, so raid just kind of makes everyone jump over there. And if I wanted to, I could just keep streaming and you could keep watching me. I could be like, lol, we got rid of all those suckers who went with the raid, and all the true fans stayed behind. We could do that now, right? Is that what happens if you bow out of the raid? You just keep watching? I've never tried that. I never bowed out of the raid and then saw if the streamer kept going and they just stayed behind saying, haha, suckers. Is that actually what happens now? That's funny. Until I end the stream. I have to remember that people might still be watching after the button, so I better not do anything stupid. Okay, see you guys. Bye. Suckers. Just kidding.